The broadcast is now starting. All attendees are in listen-only mode.
Okay, can everybody see my screen and hear me okay? Victor, can you hear me and see my screen?
Yes, ma'am.
Okay,
Yep,
great.
I can hear you.
Great, thanks. Good afternoon, everyone. Welcome to the Southern Plains El Nino and Drought Status webinar. I apologize for rescheduling this meeting due to some technical problems we had on Monday, and I'm really glad that, that everyone was flexible enough to join us today. My name's Elizabeth Waite. I'm a Regional Drought Information Coordinator for NOAA's National Integrated Drought Information System, which is also called NIDIS. In today's webinar, I'll provide a very brief overview of NIDIS and the Southern Plains Drought Early Warning System. And then I'm really looking forward to introducing Victor Murphy, who will give a summary of the drought that affected the region and concerns that still remain about the drought. And then Kyle Bray will present on El Nino, what it is, past El Nino cycles, and the El Nino forecast for this year. Victor Murphy is the Climate Services Program Manager for the National Weather Service Southern Region, which comprises New Mexico, Texas, Oklahoma, and the Gulf Coast states. And in this capacity, Victor works with the National Weather Service weather forecast offices and river forecast centers to provide partners with climate data, information, and forecasts to help ensure resiliency and mitigation and decision-making processes. Following Victor's presentation, Kyle Bray will present. Kyle is a regional climatologist and director of the Southern Regional Climate Center. The SRCC focuses on Texas, Oklahoma, Louisiana, Arkansas, Mississippi, and Tennessee. As regional climatologist, Kyle provides weekly U.S. drought monitor support. He summarizes regional climate conditions in monthly, quarterly, and yearly reports, and he performs outreach. After Victor and Kyle's presentations, I'll open the webinar for your questions. During this entire webinar, all participants are muted, so if you have a question, please type it in the box that's on the right-hand side of your screen, the GoToWebinar control panel. There's a little spot there for questions, and you can type in your questions, and then we will answer them during the Q&A at the end of the presentations. The webinar will finish in an hour, so if you have any questions remaining, you're welcome to email me. And finally, today's webinar is being recorded. The webinar recording and a written webinar brief report will be available on drought.gov. So if you're not familiar with the National Integrated Drought Information System, or NIDIS, I'm going to just do a very brief overview. NIDIS was established across the nation to provide a better understanding of how and why droughts affect society, the economy, and the environment, to improve accessibility, dissemination, and use of information for drought risk management, and to build a network of regional drought early warning systems, and to create a national drought early warning system. So you can see on the right-hand side of your screen all of the drought early warning systems, which are also called DEWs. Today's webinar is going to focus on the Southern Plains DEWs. And a critical aspect of these regional DEWs is collaborating and coordinating among agencies. And this webinar series could not happen without the input and support of NOAA's National Weather Service, the Southern Regional Climate Center, state climatologists in every state of the region, NOAA's Regional Climate Service directors, the USDA Southern Region Climate Hub, and many others. So thank you to everybody involved in putting on and organizing this webinar. And now I'm going to turn over to Victor. And thank you, Victor, for presenting today.
You're welcome. You should have my screen up there. As Elizabeth said, my name is Victor Murphy. I'm the Climate Service Program Manager for the National Weather Service Southern Region Headquarters located in Fort Worth, Texas. And without further ado, let's go ahead and get started. I'll do a brief overview here. The Southern Plains drought began pretty much in October of 2017. It peaked in May of 2018, so it was about, 8 months or so, 9 months in duration, thankfully. Very intense drought, but relatively short-lived. It was highlighted, the biggest impacts were significant wildfires in Texas Panhandle and western Oklahoma, as well as serious impacts to the winter wheat crop for both Oklahoma and Texas. New Mexico, the lack of, not only just the lack of precipitation an issue, but also the record low snowpack had an immediate impact to pasture and rangelands in 2018, and still ongoing to a certain extent. But the stream flows and reservoir levels remain very low, and quite honestly, that is the biggest concern at this time, is the very low stream flows, very low reservoir levels in New Mexico. And I have some slides that will show that later on. And moving over to Texas and New Mexico, they had a very wet summer, very wet fall, and that really has ameliorated much of the drought in Texas and Oklahoma. In fact, the state of Texas as a whole had its wettest September on record, and its third wettest month for any month of the year on record in September. And so that's done wonders as far as Texas goes. And in fact, October has pretty much picked up where September was, and we should know the final statistics from the folks at National Center for Environmental Information in a week or two, but it's very possible October will be the wettest October on record for Texas also. So back-to-back record wet months, pretty significant, and usually it's pretty good for stopping drought or ending drought, and that's sort of the case across Texas. But however, so I'll focus a lot on New Mexico as far as reservoirs and stream flows, and then most importantly, what does the winter of 2018 and 2019 hold? And then Kyle will talk about that. So this map here shows the cold winter precipitation, the cold season precipitation for the Four Corners area in the Oklahoma and Texas and New Mexico. And basically you can see from November 1 through the end of January, just about the entire area, about the entire state of New Mexico and much of northwest Texas and the Panhandle, western Oklahoma Panhandle, all saw less than 1 inch of rainfall or 1 inch of precipitation. And that continued right on into the springtime. So here's the precipitation here from March 1st through, January 1st through March 31st. And same thing here, basically less than 2 inches of rainfall or so for all of western Oklahoma, all of West Texas, but especially the panhandles of Texas and Oklahoma and northeastern New Mexico. This is sort of ground zero of the drought area going into the spring of 2018. The panhandles of Texas and Oklahoma, as well as northeastern parts of New Mexico. A lot of cities had set records, if not all-time records, at least records for the past 50 years from the number of consecutive days without measurable precipitation. And so, for example, the top left here, you can see Amarillo went 126 days without measurable precipitation, dating back to 1892. That's what, 4 months and change, but without measurable precip. Gage in northwest Oklahoma, period of record back to 1904. They had 102 consecutive days, the longest since 1956. Dodge City in southwest Kansas, 53 days, same thing there, the longest stretch since 1958. And Albuquerque, even further west, they went 96 consecutive days, and that was their longest period since 1956. So a lot of bad memories in this area here, relating back or referencing back to the drought of the mid-50s, which is sort of still the drought of record in a lot of areas around here, although a few areas surpassed it in 2011, 2012, and perhaps even with this drought. But the key word with this drought right now is the short-term duration of it, at least for now. To add insult to injury, the October through March timeframe, basically late fall, winter, into early spring, was the warmest on record for New Mexico. You can see here 123 years of records. It was warmest 6-month period on record. Same thing for Arizona. Texas and Oklahoma were pretty much about the 20th warmest or so. Either way, top 20 percentile. And of course, and not only do you have lack of precip as one significant issue, but the attendant heat adds even more stress on surface water, agriculture, wildfires, hydrology, and the snow drought. So here's a brief recap of the evolution of the Southern Plains drought. You can see mid-November, the area in here was doing pretty good. By mid-December, the drought was starting to take shape or take hold. This is after a very wet summer monsoon in 2017. By mid-January, we had some D3 or extreme drought already popping up in the Texas and Oklahoma area. By mid-February, widespread area of extreme drought had developed across the Texas and Oklahoma panhandles as well as western Oklahoma. And by the time we get to mid-March, we saw some exceptional drought, D4 in northwest Oklahoma, which increased in size by mid-April. The drought peaked pretty much here in mid-May. You can see the widespread area of extreme drought, or D3, that's lighter red, with the darker red being exceptional drought, or D4. You can see that covered the entire Oklahoma Panhandle, much of the Texas Panhandle, and the western third of Oklahoma, and by now it's covering much of New Mexico. And then by middle of June, you can see the Texas and Oklahoma portion, at least, it started to improve already. You can see a lot less reds in here. So the normal May wet season really, as you May, June, July, or April through June are the wettest months of the year here in the Texas Panhandle and the western Oklahoma. And so if you're going to break a drought, during a certain time of year, that would be the time you'd expect it to break. And sure enough, the climatology kicked in as it's supposed to. The rainfall came, the spring rains came, early summer rains came, and the drought in Texas and Oklahoma pretty much was on its way out. Once again, it was very intense, but only lasted about 8 months or so. And it's pretty much been eradicated by now, as we'll see here in a second. Not the case in New Mexico. By mid-May, they still had over half the state in exceptional drought, extreme drought, which is the D3 or the lighter red. And that's still pretty much the case right now to a large extent. So looking at specifics here, here's May 1st, Oklahoma, about the peak of the drought here. Also just the start of their wet season. You can see how bad off they were. About a third of the state was an exceptional drought. All the panhandle and the western quarter or so. Here we are as of last week's drought monitor. You can see only just a small area of severe drought, or D2, in a couple of the counties actually in northeastern Oklahoma. For Texas, same thing, May 1st. You can see a lot of the panhandles in D3, D4 drought, extremely exceptional. A lot of West Texas too. By yesterday's drought monitor, no more extreme drought in the panhandle. Maybe 1% of the state has got some exceptional drought, some extreme drought, and that would be out in far West Texas here. And I think that should be gone next week, since this week's rainfall, which fell, after the Tuesday morning cutoff of the drought monitor, this area out here, I believe, got some pretty decent rainfall. So that'll probably be gone next week also. So as of right now, the core drought area that we're holding these webinars on for Texas and Oklahoma, for Oklahoma, it's already gone. And for Texas, just a small little holdout area here in the panhandle, just covers about 4 counties or so just to the east of the Amarillo area. But once again, area of concern, New Mexico, since May 15th, they've improved. They had 64% of the state in extreme exceptional drought back on May 15th. The good news is it's down to 23%. The bad news is it's still 23%, which is quite a bit of the state. The entire northwest part of New Mexico, as well as the Four Corners area in general, also covering southwest Colorado, southeast Utah, and northeast Arizona. This is pretty much the core area now of the ongoing drought, and we'll see the impacts from that as far as stream flows, reservoirs go, etc. Some of the impacts in Oklahoma, the biggest impacts was wildfires. They had a couple major wildfires, and Governor Fallin declared a state of emergency for 52 counties due to wildfires began in April 12th. More than 350,000 acres, or 545 square feet, burned mainly in Dewey and Woodward counties in the northwest part of the state. Over 1,500 head of cattle were killed due to the fires. And also, they only had 4.3 acres of winter wheat planted on account of the incipient drought. Only 2 million acres was harvested. And this is the smallest amount that were harvested since, once again, the dreary years or sad years of the early 1950s. And also the abandonment rate was also the greatest since the early 1950s. On account of that, there's been a secretarial disaster, a USDA secretarial disaster drought declaration in place for all of the Texas portion of the drought area, the Panhandle and the northern rolling plains area, just about all of New Mexico and pretty much all of Oklahoma. has been under a USDA secretarial drought designation since June. So let's look at here at the New Mexico area. You can see the snow water equivalent in mid-April was the lowest on record for New Mexico. All these red dots here indicate pretty much near 0% snowfall and normal. And same thing extending up into southwestern Colorado. So the snow drought was very, very bad. You know, what little precip fell, unfortunately, most of it did not fall in the form of snow. So as I mentioned earlier, you can see here's the average rainfall precipitation for the Texas Climate Division 1, which is a panhandle. You can see June is when the precip spikes for this area. So if you're in a drought, odds are it should be coming to an end in June. And sure enough, it did this year, as one would expect. You know, a longer term, more prolonged drought like we saw in 2011 or 2011, 2012 would, you'd make it through this wet season without any improvement. And of course, that would be a horrific situation. So fortunately for the Texas Panhandle, the normal June rainfall and actually May, June, July rainfall, as you can see here, did develop and really, really improve things. And if anything, it's actually continued into the fall. Same thing for the Oklahoma Panhandle. Once again, June is their wettest time of the year. You can see a nice spike upward in May, through August, and that delivered also. You can see actually the blue bars here are the observed rainfall for May. So you can see for May, the Oklahoma Panhandle actually had above normal precip, and then that ramped up even more so into June. Texas started getting some precip, but we also saw a big improvement in June. So climatology delivered pretty much as you'd expect for Texas and Oklahoma portions of the drought. And New Mexico and southeast Colorado, they have a little bit different wet season. It's more of a summer monsoon driven. Their wet season is more July and August. You can see the peaks here, pretty distinct peak. Parts of New Mexico get about 40 to 50% of their year-long rainfall during the summer monsoons. And the good news going into this drought was the monsoon of 2017 was very prolific, and going into the drought, northeast New Mexico, southeast Colorado, and the Texas Oklahoma panhandles, we're coming off a very wet 2017 summertime. So that really, I think, helped keep sort of money or savings in the bank, if you will, from a water perspective, pretty deep into this drought. So here we go. After a relatively dry May, June rainfall exceeded 125% of normal across the core drought area. You can see here, this map here is from the month of June, and it's the observed rainfall percent of normal. The blues are 150% or more percent of normal rainfall for the entire month of June. So you can see how wet it was here in the northern part of Texas Panhandle and most of the Oklahoma Panhandle, as well as northwest Oklahoma. So that's where we saw the big improvements starting to take hold there. Last 120 days, it's just been very, very, very wet across, you can see almost all of Oklahoma, across almost all of Texas, especially also the drought areas. The purples here are 200% of normal, the purples are 150 to 200% of normal or more than that of rainfall. So you can see why the drought across Texas, Oklahoma has disappeared pretty quick. A couple little areas there where there is some drought persisting, or these two drier areas here. You can see the Texas Panhandle here, just east of Amarillo. Pretty much near normal rainfall, but certainly not the extreme amounts over in other parts of the state. The same thing here for northeast Oklahoma. You can see they've actually had a little part of the state here around Tulsa area and just northwest or northeast of Tulsa that's actually had below normal rainfall since June. So that's why we have these two little areas persisting of, moderate to severe drought, but they're very small in size and don't see them amounting to a whole lot. But on the other hand, New Mexico, some good rainfall this summer during the monsoon in the northeast part of the state, but the rest of the state didn't fare too well. And of course, unfortunately, the Four Corners area, the northwest part of the state, fared the worst. So basically, this is why the lack of improvement in New Mexico during what should be their wet season, the summer monsoon, July, August, September, they get about 40, 50% of their normal rainfall during that summer monsoon season. The lack of rainfall in here, now that we're into October, November time frame, you can see the odds for improvement are not that good. Actually, if you statistically, you'd expect improvement to take place during that summer monsoon time period. So let's look at the reservoir storage for New Mexico. I have two charts here. The one on the left was from June 1st, and you can see that New Mexico at that point in time, they had about 55% of their long-term average storage. This is their average storage on June 1st, statewide, and you can see what they actually had. It was about 55% of normal. Not good. Oregon's the only other western state that was below normal, but they were just barely below normal. But here we are now on October 1st, and you can see New Mexico is clearly far and away the worst off of all the western states when it comes to reservoir storage. Here's our normal level right here. Looks like about a bit more than 40,000 to 400,000 acre feet of water, and it looks like actually what they have is about 40% of that. So they're going into their drier season now with only 40% of their average reservoir levels as far as being full goes. So they are really, really in sort of high alert. The two biggest reservoirs in New Mexico, Navajo, and this is the Navajo Reservoir. Apologize for that. You can see bottom line is we go back a year here. If you go back and look at last summer, July of last year, they're up here in the 70th and 90th percentile, high cotton, if you will. That goes back to what I mentioned, the 2017 summer monsoon being very prolific. You can see how the reservoir level just spiked up, between the snow melt and the prolific summer monsoon. You can see they spiked up. But, look at this year. Here's January. The spring runoff never materialized. Summer monsoon was not very prolific. And this is, as of right now, Navajo's in the bottom 10 percentile for where it should be this time of year for an average which goes back to from 1985 through 2016, bottom 10 percentile. And that's the second largest reservoir in New Mexico. Largest reservoir, let me go back here. The largest reservoir in New Mexico is Elephant Butte. And here's where Elephant Butte stands right now. 3% of capacity, only 66,000 acre feet of storage. If you go back and look at the exact storage, it had 411,000 acre feet of water 6 months ago. So that would have been April, May, sort of its peak runoff season. They're down to 66,000 acre feet. Data here goes back to 1990, and you can see where they're at. The dashed black line here is the lowest level on record since 1990. You can see they're down beneath that right now. So that is a huge concern to all your agriculture interests in southern and southeast New Mexico, and also the country of Mexico and the state of Texas also have water compacts or water agreements in place in New Mexico to get a certain portion of water from Elephant Butte. And one more dry winter with very little snowpack could leave this reservoir in very, very dire conditions come next summer, depending upon how things shake out. And of course, Kyle will brief us on that. Here's the 7-day average stream flows for New Mexico. You can see for the month of June, you're already starting to see a lot of dryness. The brighter reds here are the lowest on record for that time of the year. The darker reds are bottom 10%. And here's where they were on June 25th, which was when we did our last webinar, I believe. And here we are, October 22nd. Even after the summer monsoon, you can see a lot of these stream flows, especially along the Animas River here in northwest New Mexico, and also along the Rio Grande here in northern New Mexico, are at record lows this time of year. And of course, the Rio Grande feeds down into Elephant Butte Reservoir. Speaking of the Rio Grande, here is the stream flow for the Rio Grande River at Taos. I'm sure a lot of you have probably been on that Taos Gorge Bridge a beautiful bridge right there over the Rio Grande. But anyway, 91 years of data. This is the USGS measuring site here. 91 years of data at Taos on the Rio Grande. The lowest stream flow they had ever was 170 CFS back in 1957. You can see what it was, 5 days ago or 4 days ago, 159. So lowest on record for the Rio Grande. Here's where it should be. Here's where it is. So you can see the significance of that. Real quick, I want to sort of break back to Amarillo and see how things improved. Back in the end of May, Amarillo area was running neck and neck with the drought 2010, 2011 for its driest start of the year on record. And it only had about 1.03 inches, 15% of normal. And here's where Amarillo is right now. They're up to 55% of normal now, and it's their fourth driest such season. So whatever drought persists in the Texas area has improved significantly. The one remaining trouble area would be right around Amarillo, or just east of Amarillo. So this is the driest year on record here, 7.5 inches, and that was back in, this is for the water year, so it starts October 1st and runs through September 30th. 2010, 2011 is the driest on record. And here we are right here in for 2017 and 2018. Looking at Gage, Oklahoma, real quick, I put this up here. So in the 2-month period from May 10th through July 10th, Gage saw almost 10 inches of rainfall, which is 5 times what they had the preceding 7 months. So starting October 1, start of the water year, through about May 10th or so, which is when the wet season begins, about 1.5 inches of rainfall. 2 months later, they had 9.73 more. So you can see the big improvement there. And so the National Weather Service Climate Prediction Center has issued an El Nino watch, 70 to 75% chance of El Nino conditions by the end of fall and into winter. This bodes very good or very well for normal to above normal precip and snowpack in New Mexico, and it also bodes well for above normal precip for Texas, Oklahoma. But like I said, Texas, Oklahoma right now pretty much already out of the woods. New Mexico certainly not out of the woods. So having that forecast verified is going to be huge. So in summary, the Texas and Oklahoma drought peaked in early to mid-May. The wet season arrived, delivered as it should. And so now I just have a few localized areas in the panhandle of Texas and northeast Oklahoma still in severe drought. The drought itself was very intense for those 8 months or so that lasted, but fortunately it was confined to the fall, winter, and early spring, which are among the drier months of the year. That's the big news there. So thus, while the percent of normal precip was very low, the actual deficits were not insurmountable, and the wet late spring and the wet summer pretty much made up the deficits across a lot of that area. So the main concern at this time is stream flows and reservoir levels in New Mexico ahead of the upcoming winter and snow season. Another dry winter and spring with little to no snow could be very, I should have put another very in there, very, very serious. And once again, the El Nino should mitigate that. We're hoping, or we're forecasting. And once again, Kyle Bray will speak more about that. And like I said, I do want to emphasize that back-to-back dry, cold seasons and another snow drought could have devastating impacts next summer for New Mexico. Considering the antecedent conditions, considering the duration and intensity of the drought so far in New Mexico, and when you consider how much of their economy is based on, rafting and skiing and outdoor activities, this could have major economic impacts for them. So, Elizabeth, I'll give it back to you.
Okay, thank you, Victor. And I'm going to turn it directly over to Kyle. Kyle, I think you're still muted.
Oh, I'm on now.
Oh, great. Perfect. Thanks. And we can see your slideshow. Thank you.
All right. Thank you very much. So I'm Kyle Bray. I'm the regional climatologist at the Southern Regional Climate Center located at LSU. And thank you to everyone for listening in on our presentation today. And thanks for Victor for his great presentation to start off with. And so he summarized what's been happening the past few weeks and the past few months. And so I'm going to talk about what we should expect in the upcoming weeks and months this coming winter with the forming El Nino. So to start out with, I'm just going to give a brief introduction on what El Nino is exactly. We're going to talk about some of the past El Nino and La Nina cycles. We'll talk about the El Nino forecast for this year, the strength and the timing. And we'll talk about how the current El Nino situation is coming together. We'll talk about conditions that we expect during typical El Nino events. And then we're going to look at the Climate Prediction Center outlooks for this winter and see how they may or may compare similarly to past events. And then we'll look at the seasonal drought outlook, and then we'll have a summary of my findings at the end. So what is El Nino? Well, it's a periodic large-scale warming of the sea surface temperatures across the central and east central Pacific. And it's the warm phase of what's known as the El Nino-Southern Oscillation. And so the cold phase is La Nina, and then the neutral phase is affectionately known as La Nada, or neutral. And so why do we care about El Nino? Well, it affects weather patterns around the world, including the southern plains, and it produces fairly reliable temperature and precipitation signals, and gives some level of predictability to what might be lying ahead in the coming seasons. So how does an El Nino get started? Well, in a traditional situation in the Western Pacific, you have a low pressure and high pressure in the Eastern Pacific, and so this causes trade winds equatorially to blow from east to west. And so essentially what you get is a pooling of warm water in the Western Pacific, and then a pooling of cool water in the Eastern Pacific off the coast of South America due to upwelling and the strong Peruvian current. But when an El Nino begins to take shape, the pressures essentially switch. And so you'll have pressure increasing in the Western Pacific and decreasing in the Eastern Pacific. So this causes the equatorial trade winds to weaken, which causes the warm water that is pooled in the Western Pacific to slowly migrate to the east. And at that point, El Nino has set in. So how do we measure El Nino? Well, one method is called the Oceanic Nino Index. And so it tracks the rolling 3-month average sea surface temperature anomalies in the East Central Pacific. So in the case of El Nino, those sea surface temperatures anomalies will be positive. And so you see there that the Pacific is broken up into 4 different Nino regions. And so the ONI focuses on the Nino 3-4 region. They're denoted with that box in the center. And so within an El Nino event, you'll have different strengths. So these are sea surface temperature anomalies in degrees Celsius. So you'll have weak, which is 0.5 to 0.9. Moderate is 1 to 1.4. Strong, 1.5 to 1.9. And then anything above that is classified loosely as very strong. So looking back at some past events, this is ENSO cycle map going back to January of 1950, and you can see the cyclical nature of El Nino and La Nina. In terms of El Ninos, we just had the strongest one on record here a couple of years ago. You can see on the right of the screen. And in terms of El Nino events that are referenced in the history books, if you will, the 2 benchmarks are generally the one that you see at 82, 83, and then the one there at 97 and 98. But you can also see within these periods that there's been several La Ninas as well. In fact, there's been a couple of cases where we've had back-to-back La Ninas. The past 2 winters, we've been in weak La Ninas. And so you see this is a cycle that every 2 to 7 years flips from one end to the other. So this graphic here is showing that most of the El Nino and frankly La Nina events fall into the weak category that we said it was between 0.5 and 0.9 degrees Celsius. And then there's been a few strong and very strong events that have taken place both for El Nino and La Nina. The most recent very strong El Nino was just a couple of years ago. And then, of course, the last 2 winters, you see that we have been in a weak La Nina. So now looking ahead to what the forecast is for this coming winter. You see there the graphic on the right. So we're looking at September, October, November 2018, October, November, December, so on and so forth. And as you can see, as we move through the late fall into the early winter stages, El Nino, there's a pretty good chance, about 70 to 75%, that it's going to form and be fully formed and maintain itself for that period of time. And frankly, looking at some of the more recent SST anomalies and other factors, I would say 70 to 75% is kind of a low estimate. So it's pretty much, we're in that transition now, and we'll continue to do so and be in that as we move on through the winter months. And so then as you get into the spring, chances are that the El Nino will fade out and transition to neutral phase, as we saw in the graphic a couple of slides ago. So this graphic is a little bit busy, but this is the El Nino strength forecast. And what I want you guys to focus on are the dynamic and statistical model averages, which are the bold red line and the bold green line. And you can see that in both cases, the averages are coming out to a weak to a maybe perhaps borderline moderate El Nino. Once again, the cutoff to moderate is sea surface temperature anomaly of 1 degree C. So the CPC outlook comes in a little bit lower than that, but if it's 0.6 or 0.8, I mean, that's not, the important factor is that there will be an El Nino, and therefore there will be impacts in the Southern Plains and Four Corners region. So we're going to take a look at some of the current situation and how things have been evolving over the past few months. So what we are looking at here is a sea surface temperature anomaly map for the Pacific. And the blue color is negative sea surface temperature anomalies. The orange and reddish colors are positive. And what you can see is a classic La Nina signature with cooler than normal SST anomalies off the coast of South America. And so this is back in January. Now moving ahead 3 months later, you can see that we are starting that transition now as the negative sea surface temperature anomalies are becoming less, have less aerial coverage, and you're starting to see more positive sea surface temperature anomalies. Now moving ahead 3 more months to July, now you can really start to see the beginnings of an El Nino signature there off the coast of South America. And now looking to the most recent map, which came out this past Monday, and you see there along the equatorial Pacific that El Nino is really starting to take effect in terms of the sea surface temperature anomalies. So the transition has been taking place for the past few months, and it is forecast to continue to do so into the winter, as I've said previously. And another indicator is looking at the subsurface temperature anomalies. So looking at this graphic, the coast of South America would be to the right, and then the Western Pacific would be to the left. So if you read the graphic from right to left, you're going from east to west. And then on the y-axis there, you see some depth. And so what this is depicting is not only are we getting positive anomalies at the surface, but we're also getting those anomalies beneath the surface as well, which just is a further indicator that El Nino is taking effect. So what should we expect in a typical El Nino situation? Well, basically what it causes is the subtropical jet you see depicted on this figure here strengthens and acts as a catalyst for storm system development, and also helps to track systems along a similar path. The northern or polar jet, which actually is not depicted on this graphic, tends to be displaced well to the north into Canada. And so in the Canadian area and the northern plains, they typically see warmer than normal temperatures. Obviously, it's still going to be cold, but relative to normal, it's going to be pretty warm. They also tend to be drier as well. But in our region, because of the more active southern branch of the jet stream and tracks of systems, we would generally expect wetter than normal conditions across much of the Four Corners region, the southern plains into the southeast, and colder than normal conditions as well, not necessarily due to more Arctic intrusions from the north, but due to cloud cover that'll dampen daytime temperatures. And so in the Tennessee Valley, Mid-Mississippi Valley, and the Ohio Valley, conditions tend to be drier due to the more favored southern storm tracks. Now, again, this is an idealized situation, and effects are not spread evenly across areas or across times, and we'll show that a little bit later on. But this is what we would typically expect, regardless of strength. So in this figure here, this shows the extreme risks for wet or dry periods or events. And then to the right, you see the risk of warm or cold events. And so looking to the figure on the left, no surprise here that across the Four Corners region, California into the Southern Plains, there's a significant percentage increase in risk of wet events. And of course, this is due to more systems theoretically tracking across the area. And so that's pretty much the type of signature you would expect there. And then across Mississippi Valley there into Tennessee, they have more of a risk of dry extremes. And then again, in the Northern Plains, as you would expect in a typical El Nino regime. Now, looking at the temperature on the right, you'll notice that while there's a couple of climate divisions, by climate division, by the way, while there's a couple of divisions in Texas that have more of an increased risk of cold extremes, that signature is not quite as prevalent, and that is to be expected considering that the cold is due mostly to dampening of daytime temperatures and not necessarily to Arctic intrusions that would provide the opportunity for records to be broken or occurred. And again, we're looking at December, January, and February when most of the effects of El Nino are felt. And so there's been a couple of weak El Ninos on recent memory. One of them was about 3 years ago, and then there's a couple in the mid-2000s. And what I'm showing here is that no two El Ninos are alike. They do tend to produce somewhat predictable patterns, but we're dealing with Mother Nature and there's always some level of variability. And so I just wanted to show that here in these two slides. So what we're looking at here are temperature anomalies for 2 of the last 3 weak El Nino events, once again, December to March or through February. And what you'll see in 2004, 2005 weak El Nino, the temperatures were above normal across basically the entire country, with the exception of the Northeast. And that would include areas of the southern region as well, in the Four Corners area. But if you look at the event in 2006 and 2007, the temperature signature is a little bit different. A lot of the Four Corners area was actually cooler than normal, whereas much of the Southeast and the rest of the country was warmer than normal. And again, this isn't much of a surprise. The most reliable El Nino signal, at least in our area, is typically the precip signal, especially along the Gulf Coast. Temperature tends to be a little bit more erratic and vary from event to event. And so that's what we're showing here. And then also in terms of precipitation. So the greenish blue areas are above normal by inch, and then the red and brown areas, yellow areas are below normal. So you can see in 2004, 2005, central Southern California, the Four Corners region and western Texas were significantly wetter than normal, which is what you would expect in an El Nino situation. Southeastern U.S. was a little bit drier, and actually the Ohio Valley was much wetter than normal, another signature that you wouldn't expect. A couple of years later, with that weak El Nino event, much of the Four Corners region was actually pretty dry. Much of the wetness was contained to the central plains, and then with a pretty sharp gradient, with the Southeast actually being significantly dry. So this again lends to the point that impacts of El Nino are not spread evenly across areas or across times and vary from event to event. So now let's look ahead to what we are looking at for this coming year and coming winter. So this is December, January, and February. And so what these maps are depicting here are probabilities. So I guess in the case of New Mexico isn't necessarily going to be more above normal than, say, southern Utah. That's sort of what it looks like here, but it's actually, we're talking about probabilities. So in short, basically almost the entire Four Corners region, much of the southern plains and the southeastern U.S. has at least a 33% chance of experiencing above normal precipitation during this El Nino event, and those chances increase then as you move south towards the Gulf Coast. And this is a classic El Nino signature, and considering the status of some of the reservoirs in New Mexico that Victor talked about before, this will be a godsend, especially for New Mexico, if this verifies. And this signature was picked up compared to the outlook that came out in September. This signature was much more pronounced. And so that can only mean good news for those areas. And then, of course, conditions have already been improving in terms of drought in the southern plains. and this the figure depicts that would continue as well. So looking at the temperature outlook, it's a little bit contrarian, I guess you would say, with what you would expect with a typical El Nino. Much of the southern plains and southwestern United States is actually forecast to experience above normal temperatures. So in terms of snowpack, that's maybe, I don't know, kind of not something that we're necessarily looking for. Of course, we want the moisture, and we'll take whatever we can get, but certainly depends on the situation at the particular time. Even if in the long term conditions are wetter and warmer than normal, there will be periods, there will be dry periods, there will be cold periods. There could be a chance that there's a heavy precip event and then an Arctic intrusion afterwards, so that snowpack is increased for a period of time, but it's just too early to predict how snowpack will be affected directly in the Four Corners region, but certainly at this rate, or this case, we'll take as much moisture as we can get. And so in response to the precipitation outlook for El Nino, this is the seasonal drought outlook, and it shows across the Four Corners region that the drought, in terms of as being depicted by the drought monitor, is going to improve and in some cases be eliminated. And this also reigns true for areas of the southern plains that are still currently depicted in drought, which is not very many areas, but there are a few. And so, you know, we certainly hope that this pans out. You know, that line of demarcation there you see in Utah and in Colorado, we certainly hope that more of that area it gets a little bit more moisture. It's impossible to tell at this point exactly how it's going to shake down, but overall, and this is through the end of January, conditions are expected to improve as we would expect with an El Nino precipitation signature. So in sum, we're currently under an El Nino watch, and El Nino has been developing as we transition from a La Nina, and is expected 70 to 75% as a low-end estimate that's going to continue through the winter. In terms of the Oceanic Nino index, it is expected to be weak, but still should be producing some of the, especially the precipitation signals that we're looking for. And so typically, although not necessarily in this case, El Nino means cooler and wetter conditions across the southern plains and Four Corners, particularly in December, January, and February, and with those effects lessening as we move through the spring. And as I've said before, events vary by strength and outcome. And so while you could expect to experience certain patterns in the long term, you do have to, from a management level, be able to assess and make changes in the short term in case there are drier or colder than normal events. And so the Climate Prediction Center outlook for the winter depicts a good chance of above normal precipitation and temperatures across the southern plains and Four Corners. Like I said before, precip, that is the typical El Nino signature. Temperature, not so much. Again, that's not surprising considering the temperature signal in our area has been a little bit more erratic across El Nino events, as I also showed those 2-week events from the mid-2000s. And so that's, you know, again, it's something that you'll have to be looking out for as time goes on. And so in response to the precipitation outlook, the seasonal drought outlook depicts improving conditions across the Four Corners area. There has been some improvement that has taken place, slow improvement that Victor showed before, not quite as significant as what's taken place in the southern plains, but it sounds like it's the turn for that area to improve as well. So this is my contact information if you want to contact me about this presentation or in general. And the Southern Regional Climate Center is also on Facebook and Twitter. And so you can find us. We post about 3 times a week at a minimum. And so that concludes my presentation, and thanks for listening. And so I guess we can turn it back to Elizabeth.
Okay, thank you very much, Kyle. was a great presentation. So everybody, all attendees, if you have questions, we have about 10 minutes available for questions for Victor or for Kyle. You can type in your questions on the right-hand side of your screen in the GoToWebinar control panel. There's a section there for questions. You can type in your questions. I think too, I can look and see. I think you can raise your hand too in the box on the right-hand side. I think you can raise your hand and I can unmute you if you have a question that you prefer to ask verbally. And if you have any overall questions about this webinar, you could contact Victor Murphy, and the contact information is on your screen, or myself, Elizabeth Waite at NOAA.gov. And as I said earlier, the webinar recording will be placed on drought.gov. In addition, we'll do a brief summary synthesis of the webinar in a 2-page format, and that will also be available on drought.gov. And we might have further drought status webinars in the future, so we'll send you out notices if there are, if we do additional webinars or status updates, we'll let you know. I don't see any questions from folks who are attending the webinar. Do you guys? Hey, Doug, I can see you're online. Am I not looking in the right place? I don't see any questions typed into the question box.
Yeah, I don't see any.
Okay, great. Well, thank you very much, Victor and Kyle, and many thanks to the organizing committee and your assistance in organizing this webinar. And for those who have attended the webinar, when you sign out, you'll be asked 2 brief questions to get your feedback on the webinar. One is the feedback on this particular webinar, and the other is to share your ideas for future webinars. Mike said, thank you for all you do. Great work as always. And Wendy Mason said the same. Thank you. Great presentation. I'll add my thanks. And thank you all for attending, and we look forward to hearing your feedback. Take care, everybody. Bye.
Thank you.
Thank you, Elizabeth.
Thank you.
Bye-bye.